10-2. We're gonna have to write some stuff after we finish this sheet, but this will make it a little less writing. That's why all of the circle unit, I gave you a lot of handouts, so you don't have to write as much. Okay. All right. So 10-2. Measuring angles and arcs. Okay. So we have something called a central angle. A central angle is an angle whose vertex is at the center of the circle and whose sides are radii. So this right here would be a central angle. Okay. All of these would be central angles because the center is at the center of the circle. Okay. Then we have something called major arcs and minor arcs. Okay, so the arcs will be the outside of the circle here. All right, so we have major arcs and minor arcs. The major arcs are the ones that are going to be less than 180. Okay. And then you have the major arcs, which will be more than 180. Usually when I talk about a minor arc, it's only going to have 2 letters. You see this one right here? You see this little arc above the GF? That tells you I'm talking about this one here. Okay. But if I want to go around this way, which is bigger than 180, I would have to give you 3 letters. So I could say G, H, then F. So you know to go in that direction. Okay. Or I could have said G, C, and then F. Okay. But I needed to use 3 letters to let you know it was a major arc compared to a minor arc. Okay. So the sum of the measure of the central angle. So all these angles together should add up to equal how much? 360 because it's a circle. Okay. Again, the major arcs are bigger than 180 and the minor arcs are less than 180. The measure of a semicircle should be 180 because it's half of 360. 2 minor arcs are congruent if and only if their corresponding central angles are congruent. So they're pretty much telling you if they have vertical angles that are equal, then you should know that their arcs are equal. Okay. The measure of an arc formed by 2 adjacent angles is the sum of the measure of the 2 arcs. So they're saying like if this one's 30 and this one's 20, then together this will be 50. That's what it's saying. Okay. The measure of the central angle equals the measure of the arc. All right. So the measure of the central angle equals the measure of the arc. The measure of the central angle equals the measure of the arc. So for example, if I asked you on this picture right here, what's the measure of arc AB? What would you tell me? 42, because that central angle is 42. That arc outside of it is 42. Okay. All right. So you have to use vertical angles, semicircles to figure out the missing parts. So like on this one, they gave me 105, 115, and 60. How can I figure out this angle? I would add those up and subtract from 360. So what would that give me? How much? 80. Same thing here. So what would that x equal? $150 degrees. Okay, on this next part, I want you to identify each arc as a major arc or a minor arc or a semicircle, and then tell me what the measure of that arc is. Okay, so I'm gonna give you 2 minutes. Okay, what did you get for the measure of arc BA?
44.
What kind of angle is it? I mean, what kind of arc is it? It's a minor arc, and it is 44 degrees. What about CD? 44, and is it major or minor? Minor. 44. What about arc BCD?
Major.
It's a semicircle. And how many degrees is it? 180. What about arc BC? It's minor. And it's 136. What about ACB? Major. And how many degrees?
316.
316. And what about AD? Minor. And how many degrees? 136. Okay. So again, to me, that's not that complicated. That should be pretty easy for you, okay? Central angle shouldn't be bad, huh? BC is less than 180. Minor arcs are less than 180. Any other questions? All right, let's go to this side. Okay, we almost done. Close. All right, arc length. Okay, so what we just did was the measure of the arc. Okay, arc length is how long the arc is. Okay, so inches, feet, that. Okay, Catherine, sit up. All right, so arc length is an arc. It's part of the circle, and it's the length of the circumference of the circle. So know that with circumference, you're finding how long the whole circle is from the outside, right? But with arc length, I don't want to know the whole thing. I just want to know part of it. So the formula for it is, they use the cursive L for arc length, equals x divided by 360 and times 2 pi r. So 2 pi r is the formula for circumference. I'm just not doing the whole circumference. I'm doing part of the circumference. Okay? So all you do, instead of x, and most books don't use x, this book uses x, we usually use m. M is the measure of that central angle. Okay, so whatever this central angle is over here, that's what you would put in for x here. So let's look at number 1. It says, use circle O to find the length of each arc, round to the nearest hundredth. So it says, find the arc DE if the radius is 2 meters. So we're going to use the formula. So looking at DE, what's the measure of my central angle? 120. So I'd have 120 divided by 360 times 2 pi. What's my radius? 2. So I'll put that in my calculator. Round to the nearest hundredth. And what would you get? 4.19 meters. Okay, 4.19 meters. So the m over 360 or the x over 360 is saying just that part instead of finding the whole circumference. Okay. Any questions about that? All right, so you're responsible for the rest of that part. Okay. All right, now let's turn the page. We're going to still do arc length, but we're going to do it with radian. Okay, so you also have to know how to do arc length if I give it to you in radian. So y'all actually did the unit circle in pre-AP. In regular, we don't do the unit circle, but they still have to know how to do arc length in radian. So the formula looks like this. What is this symbol here? No, that is theta. Theta, and the theta represents the angle. Okay, so let me draw a picture actually like this. Let's draw a picture. So this angle right here, that's my theta. Then the radius, of course, is there. And then the arc length would be from here to here. Would be the outside of it, okay? So the theta would be my angle. The arc length would be this. And then the radius would be this. Okay, I'm going to do one example. Okay, so draw this picture here. We're going to find the length of ZY. The way you know that you're going to use the radian formula is that you don't have degrees, okay? On the other one we just did with that x over 360, 360 represents degrees. So you can't use this one. You can't use 3 pi over 7 because that's not degrees, that's radian, okay? That is not degrees, that is radian. So that means you're going to use the theta equals the arc length divided by the radius. So all we're going to do is plug in the formula. It's still not hard. You just still plugging into the formula. So what's my theta? 3 pi divided by 7 equals, do I know my arc length? No, I'm trying to find it. Divided by what's my radius? 5. So if I want to get the arc length by itself, how can I get rid of that divided by 5? I can multiply by 5. So it can cancel. Times 5 here. So realize the 5 would only multiply to the actual 3, because it would be like, this would be a better representation of multiplying by 5. Okay? So it would be 15 pi divided by 7 equals the arc length. And can I reduce 15 over 7?
Yes.
No. So I can leave it like that. Okay? If you see the answers in decimal form, then you would just put it in the calculator. But that's the exact number for the radian arc length. Okay? Any questions about arc length and radian? All right. All right, 2 more things. So we have how to change percent to central angle measure. And you're going to have a project that deals with this at the end of the circle unit too. I don't have a whole bunch of this. Okay, so draw this circle graph. So realize that these percentages are not the central angles. These are percentages. So we would need to change them to the central angle or vice versa, okay? So how much is a percentage out of? So Jazz, 40%, how much is it out of?
100.
Out of 100. And if I want to do a central angle, what would that central angle be out of? 360. And since I don't know the angle measure, it would be x out of 360. So then what would I need to do? Cross multiply. So I have 40 times 360. $14,400 equals 100x. So then I would divide by 100. So x would equal what?
144.
144 degrees. Okay. So that's how you convert from percent to central angle measure. And you would do it the opposite way if you were looking for the percentage. Okay. All right, last thing. You might can fit this at the bottom. Okay, converting from degrees to radian. Converting from degrees to radian. All right, so to convert from degrees to radian, Remember on the circle, on the unit circle, I had degrees and radian for each section, okay? So if I ask you what does 160 degrees equal, you should be able to tell me how much it equals in radian. So that's what we're going to do. We're going to do an example. Okay, it's two different ways, but I'm going to show you this way. All right, so for radian, you take the degree times 180. I mean, times, not times 180. The degree times pi and divide by 180. If I give you the degree, if you want the degree, you would take the radian times 180 and divide by pi. Okay, so you're going to use either you're looking for the radian or you're looking for the degree. So in this example, which one would I be using, the first one or the second one? I'm going to use the first one. So all I'm going to do is plug into my formula. So the radian equals degree. What's my degree? 140 times pi divided by 180. And can I simplify 140 over 180?
Yes.
Yes, I definitely can cross out the zeros. And then 14 and 18, can I reduce that some more? I can divide by what? I can divide by 2. So I'd have 7 pi divided by 9. And that would be my answer for changing from degree to radian. Okay. No, you leave it like that. Okay.